In my never-ending quest for shitty electronic products on eBay, I've come across another battery charger. So this one came from, Yonghui Wholesale. It's rather distinctly called USB 3 salts universal charger for AA nickel metal hydride, nickel cadmium rechargeable. £1.20, that's quite an interesting price. And look at the pictures here, and it looks like the plugs are sort of translucent. Mine's not translucent, mine's sort of jet black. But I think there's something in this plug because it's far too big to be an ordinary plug. I get the feeling from the battery contacts, it's the conventional battery pack type contacts here with the springs and the plates at the end. I get the feeling these may just be in series. Where's my screwdriver? Let's open it up. Oh, that's a bad start. Thinner, something thinner. Here we go. So what's going to be inside? Actually, I'm wondering if this is a standard lithium charger they're using with the nickel metal hydride cells. My own experiments with that didn't really work out that well because it terminates at the 4.2 volts, and but when you've put a set of nickel metal hydride cells in, they actually go up to about 4.5 volts before they're fully, and they sit there for a while before they're fully charged. It's not as predictable as a lithium cell. These nickel metal hydride cells, you have to either trickle charge them for a longer than their capacity, so to speak, or use fairly sophisticated techniques to measure sudden fluctuation in the voltage. This is very, very empty. It really is just the wire coming in. They've actually got a little hole in the back with a label over it for an LED in there. But really it's just the battery holder. Okay, rightio. I'll pop this back on then. I'm liking the case. Actually, you know what? Just for the case alone, this isn't actually that bad. You could almost, you could put a row of LEDs along there and just use it as an angled sort of wash light against the wall with very accessible batteries. I'm just thinking reasons that I could use this. I'm not sure what the, I'm not sure what that little slot there's for. It's like something's designed to go in and lock. Maybe it is. Maybe it's one of those sort of Kingston lock type things, slots. Although they're never that secure, you'd think that you could just rip them out. So let's put this in, let's open the other bit and see if there's any active electronics. Although to be honest, I'm not thinking there's going to be active electronics. How can we test that? I know how we can test that. Let's plug it into this and get a meter in and put it to continuity. Put it to continuity and just see if it's going straight to the leads. It might be going straight to the leads, the battery. Negative. That's going straight there, which means that would be the positive. Oh, right, okay. Is that going straight there? Or is there going to be a resistor in series? That's no real resistance. What about the negative? Oh no, we've got a resistor. Looks like 5 ohms or thereabouts. Okay. That's probably in the plug then. Let's open the plug. I'll just zoom in a little bit on this. It's very dark, mainly because it's jet black. Is the spudger going to open this? Oh, it's looking very promising. It's making creaking noises. Oh, it's held together by an interesting thing. This looks like it's actually wrapped round. Is this going to liberate it? If I use unreasonable force, am I going to stab myself? Oh, I've snapped it off completely. That's okay, I didn't like it anyway. Oh, right, it's open, it's open, it's open. Or it's partially open. Get the spudger in and use a little bit more force to liberate the secrets, which are probably a resistor. Right, no subtlety. It's open. Oh, right, okay, that's odd. There's a resistor, plus there's an LED and a transistor, which may be a voltage threshold detection. That's kind of well jammed in. Oh, it's actually forming part of the plastic of the plug, I think. Oh, it is. That's it. The metal section of the plug is actually, I've really burst this. Oh, that's okay. I have no problem with that. Right, okay, I'm just going to test this a bit further. Be back in a moment. Okay, so it does light up. The case is translucent enough that it does produce a bright red dot in the case. And the circuit board is extremely simple. All it's doing is it's a current level detector, because it's got a 3.9 ohm resistor in series of the batteries and a transistor. And the only other circuitry in this is a resistor to limit the current through the LED, which is then switched by the transistor. And there's also a position for another LED, which would presumably be green, with a resistor in series, so it's always on all the time. It's presumably doing that trick that they use, the standard gallium phosphide LEDs, the dull green ones. And it means that when current ceases to flow, or the voltage across the cells is high enough that the current through this drops to the threshold that the transistor turns off, then the red LED would go out and the green LED would be visible, and that would be like the charged state. But they've missed that bit off. Probably because I think it just stays lit all the time. The circuitry. The charge LED. The circuitry is like this. There's the LED that's not used. It's the green LED, presumably. So let's put a G next to that for the green. Here's the LED that is used with a standard NPN transistor. There's the batteries being charged with the external connections to this little module here. And the current flows through this resistor. And if you work it out, based on the voltage being 0.6 volts that this transistor will turn on, it's a bit naughty, because if the current is very high, to the point the voltage above this goes above 0.6 volts, a lot of the current is just flowing through the transistor from the base to the emitter. I guess they're just basically allowing for that. But based on that, the current through the resistor to achieve 0.6 volts with a 3.9 ohm resistor is 154 milliamps. So anything above 154 milliamps will make this transistor turn on and this LED light. But also, as the voltage across these cells rises, it usually goes up to about 1.5 volts. Then as soon as it gets up to the full 3 in series 4.5 volts, then the voltage across this on a 5 volt USB supply is going to drop below the 0.6 volts anyway. So as soon as these get up to roughly 1.5 volts, then the transistor is going to turn off and the LED is going to go out anyway. It's a very rough and ready indication. It's not going to give you a true indication of the charge state of the cells, which will depend on how new the cells are, what the capacity is, various variables, because you can't just standardise on nickel metal hydride cells. The voltage in the fully charged state can vary quite dramatically between cells. But it's an interesting enough little circuit. The best thing about this is the case. I do like this case. It's quite a smart case. The fact it acts as a sort of battery holder, but with the batteries fully accessible, you can just pop them out, is quite nice. So yeah, it's reasonable enough. It's quite an interesting little thing. It sort of cheats a bit, but you know, it's all right. I suppose it does the job.